This problem is similar to what we did before. Given an argument, we want to determine if this argument is valid or invalid. If it's invalid, what kind of error that this argument has. So it's either the converse error or the inverse error. So we need to determine that, and also justify our answers if it's valid. So how do we justify our answer if it's true? Then if it's this argument is valid, then it's we either use modus ponens or modus tollens, this kind of argument. So let's look at this example. No polynomial functions have horizontal asymptotes. This function has a horizontal asymptote. This function is not a polynomial function. So we first let's convert the first statement to the form we are used to for any and there exists form. So no polynomial functions have horizontal asymptotes. That pretty much means for any polynomial function. Let's use f to describe it. F does not have horizontal asymptotes. Does not have horizontal asymptotes. So this is a universal statement. This works for any polynomial function. Well, so the second sentence, there should be a therefore here. So this function has a horizontal asymptote. Well, that's the negation of the conclusion. We know by contrapositive, if the negation of the conclusion is true, then the negation of the hypothesis should be true. So this is saying this function f has a horizontal asymptote. Therefore, f, because has one and does not have one, that's the negation of each other. So therefore, by contrapositive, we know that this f should not be a polynomial function, because if it is a polynomial function, then this f should not have a horizontal asymptotes. If it does have, and that means it's not a polynomial function. So the conclusion, f is not a polynomial function. And that is a valid argument. And this argument is universal. Well, it is still modus tollens, but because universal statement is involved, so this is universal modus tollens, and we applied a specific case of a polynomial function f, because this universal statement applies to any polynomial function, so it should apply to a specific polynomial function f. Okay, so this we would say this is a valid statement argument, and by the reason is this is pretty much this argument is universal modus tollens. Well, if suppose we say we change it, well, of course we know there's two arrows. If we change this statement to the second sentence to, so if f so if we look at the next example, we make some we keep the first statement, so we still keep that, and so let me type this down here. Now we look at the other three arguments here. So this is our first argument that is valid. Now let's look at the second one, third and fourth. So the first statement is still true. So they all of them share the same premises here. So I didn't want to type them 3 times. So just remember they all share this first premise. So the second argument says f is not a polynomial. Therefore, f has horizontal asymptotes. Well, as we can see, f is not polynomial. That's the negation of the hypothesis. So this is conditional you can actually write this as a conditional statement for any polynomial f if f for any function f if f is a polynomial. So instead of saying them together, we can separate them into 2. Now it becomes conditional statement. So this is if f is not a polynomial, which means that's a negation of the condition, and therefore we negate the consequence. As we know, this type of statement is the inverse, and we know inverse argument is not this logically equivalent to original statement. So this is an inverse error. And number 5. So for any function f, if f is a polynomial, then f does not have horizontal asymptotes. F does not have horizontal asymptotes. That's the conclusion of the conditional statement. Therefore, f is a polynomial, and that's exactly the converse. And we know converse is not necessarily equivalent to the original statement. So this is a converse error. And the last one, again, we use the same premise. For any function f, if f is a polynomial, then f does not have horizontal asymptotes. F is a polynomial function. Therefore, f does not have horizontal asymptotes. So if it meets the condition, then we will definitely have the conclusion. So this is a valid argument. I should put invalid here. Invalid. And it's a converse error here, inverse error here. And this is a valid argument. That's by universal modus ponens.